Hey, good morning, guys. Assalamu alaikum. Welcome back to Inspired Teens Grade 11 Mathematics. So in today's lesson, we will be continuing with functions. Okay, so just give me 1 second. Okay, so yeah, sorry. Firstly, sorry for all the delays. It's just living in this country, we currently have load shedding and no water, so that always poses challenges that you couldn't prepare for. Okay, but nevertheless, let us begin. So last time what we discussed was distance. Okay, we discussed vertical distance and horizontal distance, as well as the maximum or minimum distances of the two. Okay, and we did a question example. Okay, and in today's lesson, we're going to continue from roots and parabolas. Okay, so let's have a look. So when we deal with roots and parabolas, roots of parabolas basically, okay, we need to understand that a root is an x-intercept. When we use the word root, okay, we are talking about the x-intercept of a graph, okay, that gives us its roots. Okay, so that's to clarify, when we talk about roots, we're talking about the x-intercepts of a graph. Okay, the first instance, okay, is when you want to know, okay, if a parabola has equal/real roots. Okay, so firstly, the difference between having real roots and having non-real roots, okay, is when they actually have intercepts compared to when the graph does not have intercepts. So we can look at the first example, equal real roots. We can see that there's an x-intercept. If we look at the second example, Okay. The second example says no real roots. As you can see, this parabola will never have an x-intercept because it will never touch the graph. It will never touch the x-intercept, sorry. And here we have real unequal roots. We'll get to each of them in a second, but here we can see that they are x-intercepts. Okay, so real roots means that they are x-intercepts, and non-real roots, right, means that they are no x-intercepts. So again, in the first one, right, we have equal real roots. So whenever we have equal real roots, that just means that in the parabola graph, we have one x-intercept. So technically we have two, and we say that they are equal because they are at the same point, essentially. Okay, so this is when the turning point is the x-intercept. In this case, this guy here is our turning point. Let's do this. Okay, this guy is our turning point. Okay, and when we, in the case of equal real roots, that is when the xTP is on the x-intercept. The xTP is the x-intercept, or the turning point is the x-intercept. Okay, and we can describe all of them in terms of the discriminant. So remember, our discriminant is delta is equal to b squared minus 4ac. Okay, so this b squared minus 4ac, this is known as our discriminant, and this we can have each one for each instance. So for example, for the first one, when we have equal real roots, then b squared, or the discriminant, b squared minus 4ac, okay, is equal to 0. So when you take, so this b and a and c, these come from the quadratic equation of the parabola function. So the standard form is ax squared plus bx plus c. That a, b, and c, when you sub it in here, it should give you 0 if they are equal real roots, meaning if the turning point is on the x-intercept, that's when b squared minus 4ac will definitely give you 0. Okay, then we have the next one, non-real or no real roots. Okay, essentially non-real roots. When we have no real roots, okay, this is when there are no x-intercepts of the graph. Okay, and then these are the two examples when the turning point is above the x-axis or below the x-axis. Okay, and in this case, b squared minus 4ac, the discriminant, is less than 0. Okay, b squared minus 4ac, or the discriminant, is less than 0. Then we have the last and final one. When we have real equal roots, so this is when we have two x-intercepts on a parabola function, then b squared minus 4ac is actually greater than 0. Okay, so pretty simple to remember. When we have equal real roots, so why are they saying roots plural? When we have one x-intercept, technically we have two x-intercepts. It's just that they both have the same coordinate, which are the turning points, or the turning point. Okay, so when we have equal real roots, that's when the turning point is the x on the x-intercept, or on the x-axis, or the turning point is the x-intercept. When we have no real or non-real roots, b squared minus 4ac less than 0, that means we have no x-intercepts on our parabola graph. And when we have real unequal roots, b squared minus 4ac is greater than 0. This is the most common one when we have two x-intercepts. Okay, so that's what we need to understand when it comes to roots and parabolas. Okay, let's quickly do an example of how they could ask the question. They said here, the value of k, find the value of k essentially, find the value of k for which negative 2x squared minus 8x plus k has two equal real roots, or two equal roots. So remember, from our notes, we need to remember that two equal roots means that b squared minus 4ac is equal to 0. Okay, when a graph has two equal roots, the discriminant is equal to 0 and the turning point is on the x-axis. So what we can do is, this equation has an unknown value of k. They want us to find the value of k for which it has two equal real roots. Okay, and here's the function given, minus 2x squared minus 8x plus k. So what we need to do is we can substitute the values of b, a, and c into this formula and then solve for k. Okay, so b squared would be negative 8 squared, okay, minus 4 into a, negative 2, into C. Now C is K, because it's given a value of K. It's not, doesn't have an actual value. And we equate this to 0. Okay, and now we essentially solve for K. So this gives us 64. This gives us positive 8K, and that gives us 0. Eventually we get 8K is equal to negative 64, and K is equal to negative 8. Okay, so this is an example of a question of how they could test your knowledge of roots in parabola. The value of K, for which negative 2x squared plus minus 8K minus 8x plus K has 2 equal real roots. We have to formulate an equation for the discriminant and equate it to 0. That's how we solve it. Okay, let us move on. Let us talk about the intersection of graphs. The intersection of graphs. Okay, so let's read the steps and then do a practical example. Steps for determining points of interception. Equate the two functions, number 1. Okay, so that's always the first step. You need to understand that the points at which two graphs intersect is the point at which their values are equal. Their coordinates are exactly the same. So the coordinates of A, okay, they are coordinates for the straight line graph and the parabola graph, and the coordinates for B, they are coordinates for the straight line graph and the parabola graph. Okay, both of them. Make sure the screen is not too blurry. Okay, should that is in that. Okay, so just keep that in mind. So therefore, that's why we can equate the two equations, because here we know that the y values are the same for A and the y values are the same for B. That's certain, right? And so too, it's the same thing for the x values. So in this case, remember, this is essentially saying y is equal to y. So it makes sense to equate the two equations, okay, equate the two functions to find the point of intersection, whatever, but I think they're the same thing, all right? So that's why whenever you have two graphs meeting each other at a certain point, if you want to find that coordinate where they meet, you can equate the two functions or the two equations, and you'd be able to solve for the coordinates. Okay, so equate the two functions, solve for x, look for the applicable x value, x or A or B, substitute the applicable x value into any of the two equations to find y. Let's do that practically, and that will make more sense. Okay, so firstly, we are given the equations. We have g of x is equal to negative 2x plus 4, and we are given that f of x is equal to x squared plus 3x minus 2. Okay, so let us solve. So firstly, I'm going to equate the two functions. I'm going to say f of x is equal to g of x. Okay, this is the main step, understanding that you need to equate the two. Okay, now I'm going to solve for this. So I'm going to say x squared plus 3x minus 2 is equal to minus 2x plus 4. Okay, so this is equating the two equations. I've taken f of x, placed it there. I've taken g of x, and I've placed it there. So I'm equating the two equations. Now I need to rearrange this to get all the variables and all the numbers on one side and let it equal to 0. Okay, and then I'll formulate the new equation. Okay, so let's take everything over. So I'm going to have x squared plus 3x. Bring this guy over, it becomes plus 2x. Minus 2, bring this guy over, it becomes minus 4 and equals to 0. If I simplify like terms, x squared, this gives me 3x plus 2x gives me 5x. Minus 2 minus 4 gives me minus 6 equals to 0. So I formed a new equation. So what I do now is I factorize this equation, and it's going to give me x coordinates. It's going to give me x coordinates of the point of intersection. So it's quite simple, right? Equate the two equations, formulate a new equation, factorize to find the x-intercepts, right? Because this is equal to 0 for the x coordinates. Okay, so now I can, if I factorize this, I get x plus 6x minus 1. X plus 6x minus 1. Does that 100% work? Yeah. So therefore, x plus 6 is equal to 0, or x minus 1 is equal to 0. So x is equal to negative 6, or x is equal to 1. These are the x values of the points of intersection of the two graphs. Now, we've done that. We've equated the two functions and solved for x. look for the applicable x value, A or B. So now you have to use discretion, okay, to determine which one is 1 and which one is -6. So of course, the one that's more left is going to be more negative, and the one that's more right is going to be more positive. So therefore, B has to have a coordinate of 1, and A has to have a coordinate of -6. Okay. Now, let's solve for the y coordinates. So it just says substitute the applicable x value into any of the two equations to find y. So yes, that's 100% true. Substitute it into the easier one, which is g of x. It doesn't have any squared terms or anything like that. So I can substitute it into g of x, okay, to form to get the corresponding y coordinate. So I'll call this x1 and I'll call this x2. Now I want to find y1. So y1 is going to be equal to this equation, but with x1 substituted into it. So g of x is equal to -2, open brackets, I'll take x1, -6, okay, plus 4. So this gives me a y1 value of +12 plus 4, 16. Okay, let's find y2. y2 is going to be -2 into 1 plus 4. This is going to give me a y2 of 2, I believe. Okay, so if we have to form the first coordinate, which is actually, we chose x1 for A, so we can say that A's coordinates are -6 and 16, and B's coordinates are 1 and 2. So let's fill that in here. This is going to be 16, and this is going to be 2. So you'll see it also makes sense, because obviously 16 has to be higher than 2, and that's why it makes sense that this guy was 16. Okay, so, and that's how we solve for the intersection of graphs. Okay, so I hope that makes sense. It's not too difficult, it's pretty straightforward, right? Okay, if there's any questions, please. Okay, let's see. Use the following space on the question every time. Is there no set formula? Yes, correct. So like, are you talking about like this? You equate the two functions, f of x is equal to g of x. Okay, so there's no set, right? There's no, you're not going to always use this formula here and that formula there. Okay, what you're going to do is, yes, it's going to be based on the question every time. So whatever the function of the question of each graph is, that's the two that you're going to use to equate. You're going to equate those two together to solve for the question. Okay, let us move on, right? Let us discuss increasing slash decreasing functions. Okay, so we sort of already discussed this, maybe, I think, in parabola at some point, but we're going to quickly discuss it again. So the easiest way to solve for this is to always look from left to right. This is the key. You need to look from left to right. Always, 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 always look from left to right, and then it's easy to determine, right? So let's have a look here, right? We draw our little guy again here, Bob. Okay, and if Bob finds himself right here on top of this parabola graph, right, you as a student have to ask yourself a question. Moving from left to right, so that's always the clarification you need to make. You always need to be moving from left to right. Okay, if Bob is finding himself on top here, if he has to move from left to right, is he going to slide down to his death, shameful guy, or is he going to have to climb up? Okay, so it's clear that from left to right, from here all the way up till here, Bob is going to slide down. Okay, and sliding down represents decreasing, of course, up until this point here. Okay, so up until this point, the turning point, then we have Bob, and he finds himself here again now at the turning point. Okay, when Bob is moving from left to right, is he going to have to slide down this path or climb up it? And it is clear that he's going to climb, and climb represents an increasing function. Okay, so the trick is just to always move from left to right, move from left to right, because if you're going to move from right to left, then it's going to be opposite, right? But we don't have to move from right to left. We always move from left to right. That's the key. Okay, so always keep that in mind. So similarly here, if Bob finds himself here, this would be increasing because he has to climb up it all the way till the turning point. And once he reaches the turning point, he falls back down, and that's a decreasing function. Okay, when he finds himself up top. Okay, so you can always move from left to right. Technically, you're always looking from left to right. What we look for is y value increasing. Okay, we always look for the y value increasing, but you don't necessarily have to. If you understand moving from left to right, that's perfectly fine. But the technical understanding is that the y value increases. So when the y value is increasing, that represents an increasing function. When the y value decreases, that represents a decreasing function. Okay, so yes, increasing, decreasing. Anything else to discuss? Doesn't seem like. Let's move on here. Okay, let's look at now some. We're going to determine the x values for which a graph is increasing, because these are common questions, right? Determine the x values for which the graph is increasing, as well as these interval notations that we deal with, right? X is greater than 0, f of x is greater than 0, f of x is greater than g of x, and all of those good stuff. Okay, so one important note here that's written is, of course, very important. It says that x at the turning point, the graph is not increasing, nor is it decreasing. So we should understand that at the turning point, the graph is neither increasing nor decreasing. So at that point. So we don't include it in our questions, essentially. That's what it's going to help us to remember. We don't include it. When we write our answer as an interval or as an inequality, sorry, to say that the graph is increasing from the turning point to infinity, for example, from here to here, okay, we won't include the turning point, because at the turning point, it's neither increasing nor decreasing. It's like flat, essentially. Okay, so cool, right? Just always remember that. Now they want us to determine for which x values. Now this first one, f of x is increasing. So let us try and determine the x values for which f of x is increasing. So again, we have to look for the parts of the graph from left to right, which are up and down. Okay, so if it's a parabola graph, you can draw your guy, Bob. Okay, and clearly you'll have to climb up until this point where it's neither increasing nor decreasing. Then you'll have to slide down. We always work from left to right. So therefore, we understand that the increasing part of the graph is right here, up until the turning point. Let's not do that. Okay, up until the turning point, which is somewhere there. Let's stop it here. Okay, so we have to determine the x values for which this graph is increasing. Now, whenever we want to use x values, of course, we are only going to look at x values. And now that sounds silly, but what I'm trying to get at is many people get confused as to how to answer these interval questions. Okay, so what you want to do is your first step is to identify the part of the graph that is true for whatever restriction the question gives you. In this case, they want us to find the x values for which f of x is increasing. So you can use a highlighter if you'd like, if it doesn't confuse the rest of your questions, right? And identify the part of the graph that they're talking about. So in this case, they're talking about f of x increasing. I've identified that part of the graph. Okay, that's the easy part, actually. Identifying the part of the graph that they're talking about. That's done, it's highlighted. Now you need to go to the starting point of that highlighted portion and the ending point of the highlighted portion. You write the x value of the starting point and you write the end value of the x value of the ending point. That's how you answer it. Okay, so if we look here, the highlighted portion of the graph, we are going to try and answer this in terms of x values. Okay, so the starting point of this highlighted portion, it starts here. Okay, but we know that essentially this is going to go to infinity. So it actually starts at an infinite value. And okay, we'll get to that. And it ends right here at what is the turning point, for sure. Right, because that's where the graph stops increasing, because at turning point, it's neither increasing nor decreasing. So the graph stops increasing at the turning point. Okay, so now what we're going to do is we actually need to find the coordinate of the turning point. Our starting x value needs to be here. Okay, going left, the most left value of this graph possible, and that would be negative infinity as an x value. And our ending value would be the turning point value. But the x coordinate, right? Remember, they generally always ask, give it in terms of x coordinates, right? Many people confuse it and put y coordinates, or they don't know what to put, but always x coordinates. So the x coordinates is simple, can be found out because we know that the two x intercepts, we can find their midpoint. So we can simply say 5 plus negative 2 over 2, and that's going to give us 3 over 2, which is 1,5, which can be found somewhere here. Okay, 3/2. So when we give our final answer, I'm going to do it both ways. Firstly, x is an element of. So the way I'm going to teach it, if you get confused by, if you really despise interval questions, if you really despise this type of questions and they always confuse you, I would recommend that you follow what I'm going to teach, okay, and always use the, what do you even call this, like this notation here with the intervals. Okay, x is an element of, and then we use brackets, big, small, square brackets or circle brackets. Okay, so if you really are confused by this, I would recommend following using this bracket, because the way that I'm going to explain it really makes sense using this notation. However, you can use the inequality notation as well if you understand that. Okay, so here we're going to say x is an element of, and I don't know if you guys remember, but I taught you guys in parabola, I think, yes, when we discuss range and domain, okay, we discuss how far right, how far left, how far up, how far down. But this is the important thing, that this is the knowledge that we need to take over. X is an element of a starting value and an ending value. And because for the interval notations, they generally always ask in terms of x, is going to be a most left value and a most right value. This is very important. This is what we need to take over. X is an element of a start value and an end value. Okay, and that's the same thing essentially that we are doing here. We are trying to find x is an element of its start value and its end value. And since we're working with f, we are talking about x, sorry, not f, we're working with x. It's going to be the most left value and the most right value. And that's what we're going to do. So we've established that the most left value here is negative infinity. We never include infinity, just to, okay, we'll revise it in a second. Yeah, right. Remember that circle bracket is exclude, square bracket is include. Okay, we never include positive or negative infinity, and we never include asymptotes. Okay, so let's go back here. Okay, so x is an element of the most left value, or the start value. That's going to be negative infinity. Okay, and the ending value is the turning point, x value, which we've got, right, 3/2. Now, the important thing here, do we include or exclude the turning point? Okay, we actually exclude the turning point for the main reason that the turning point, at the turning point, the graph is neither increasing nor decreasing. So we exclude it, because remember, what is this interval for? This interval is for the graph increasing, the values, the x values for which the graph is increasing. So it starts at negative infinity, because it's always going to be increasing from negative infinity, always increasing from negative infinity until it gets to the turning point where it stops increasing and decreasing. And then after the turning point, it starts decreasing. So that's the answer here. Alternatively, for the interval notation, we could also say x is less than, okay, we need to work with that. So you can even say x is greater than negative infinity, or less than turning point, or you can simply just say x is less than the turning point, which is 3/2. Okay, and what we're gonna do is we don't include, because the reason we don't include is because at the turning point, it is neither increasing nor decreasing. Okay, so let's move on to this one, where they say find the x values for which f of x is decreasing, and the x values for which f of x is decreasing. So let's have a look at this graph. The first step is to identify the part of the graph that they're talking about. The TP was the midpoint formula, correct? Because when you have the x-intercepts, you can always get the turning point using midpoint. Okay, we did it in the parabola in one of the first function lessons when we did parabola. Okay, essentially, when you have the two x-intercepts, you can use midpoint formula to find the turning point. So you need to remember that the x-TP, the x-coordinate of the turning point, is the midpoint of the x-intercepts always. Okay, so yes, f of x is decreasing. The first step is to identify the part of the graph that they're talking about. In this case, it's the decreasing part, and that's the easier thing to do, because when Bob is over here, we know that this is the part where he's going to go sliding down. Okay, so it's this part of the graph that's decreasing, stopping at the turning point. Okay, so now we need to express this in terms of x values, right? That's what they want us to do. They want us to find the x values for which f of x is decreasing. So remember, I'm going to write it again. X needs to be an element of its start value and its end value. And in terms of x, start is most left. In terms of x, end is most right. So that's what we're going to look for, right? We're going to look for the most left value and the most right value. So yes, the most left value is here. Okay, at the turning point, the most right value actually goes on till positive infinity. So our answer here is going to be x is an element of starting value. I exclude because it is the turning point, and at the turning point it is neither increasing nor decreasing. Okay, so I cannot include it. The turning point is 3/2. This is the same graph that was given. Okay, 3/2, and x ends at this value, which goes on forever to the right, the most right value, which is positive infinity. So it ends at positive infinity, and you never include infinity. Okay, now let's deal in terms of the other notation. You can simply just say x is greater than 3/2. Okay, but again, if you're struggling with this, I would really recommend you use this just for the concept of start value, end value, most left value, most right value, and slotting them in there. Okay, so those are increasing, decreasing. Don't worry, we're going to do plenty more. I just want to add one more thing about excluding and including here, right? Remember for the other notation as well. So here we have what do you call it, circle bracket, or alternatively we could also have that thingy. Okay, and here for include, okay, we could have, for the other notation, instead of just greater than, we could have greater than or equal to. That's how we represent it with the other notation. So the top two represent exclude, the bottom two represent include. Okay, just want to clarify that. Okay, and yeah, we never include those things. Okay, let's have a look at the next examples. Okay, so determine for which x values x is greater than 0. Okay, so this is a bit of a silly, trivial example. However, it's just, I want us to go through it to understand when they do ask this as well. So determine for which x values x is greater than 0. So firstly, we need to understand when is x greater than 0. Okay, and always, this is always the case, x is greater than 0 always to the right of the y-axis. Okay, x is always greater than 0 to the right of the y-axis. Okay, so now that's what x is greater than 0 means. We have to identify the part of the graph that's to the right of the y-axis. Again, like I said, this is the easy part. Oops. There we go. No, don't straighten, man. Sorry, OCD. Okay, so there we have highlighted the part of the graph where x is greater than 0 or x is to the right of the y-axis. We've highlighted the part of the graph where x is to the right of the y-axis. Now, let us write that in terms of x values, right? So what we're going to have here, we're going to have x is an element of, okay, we need to have a start value and an end value. So most left value is here. Okay, the most left value is here. We're talking about, yeah, in terms of x coordinates. So the most left value is here. And we do have its x coordinate because this is actually the y-axis. So the y-axis is the y on the y-axis, all the x coordinates are 0. Okay, so our most left value, okay, just keep in mind, is here. Our most left value is here. That's a bit too big. Our most left value is here. Our most right value is there. Okay, but obviously it's positive infinity. So this is another thing I wanted to tell you. Because we're dealing with x coordinates, another thing you could do is draw a vertical straight line or dotted lines to the x-axis like this, to the left point, and that coordinate is the x starting point, and here that coordinate is the x ending point. Okay, but obviously this one, this right hand side would be positive infinity. So it starts at 0 and ends at infinity. Okay, so do we include 0 Okay, so we know infinity we're never going to include, but you include 0. So you always, in this case, you always look to the question. Does this question want where x is greater than or equal to 0, or does it just want where x is greater than 0? In this case, the question doesn't include, so we won't include. So we don't include 0, and we don't include infinity because we never include infinity. So x is an element of 0 to infinity, or alternatively, you could just say x is greater than 0. So yeah, this is, they never asked this question. I just wanted to go through it because determine the x value, so which x is greater than 0. X is greater than 0, right? It's answer is the question. Okay, let's look at this. Determine the x value, so which x is less than or equal to 0. So x is less than or equal to 0 where? To the left of the x of the y-axis, to the left of y-axis. Anything that's to the left of the y-axis will have an x-coordinate that is negative, or an x-coordinate that is less than 0. Okay, so we have it here. That's the part of the graph that's to the left of the y-axis. Now we express this in terms of x values. We're going to say x is an element of, the starting value is the most left value. The most left value is here, which goes on till negative infinity. So x is an element of, negative infinity. Of course, we cannot include negative infinity. And x is an ending value. We end here. We end at that point. That's the most right point that is to the left of the y-axis. That's the most right point that where x is less than 0. Okay, so in this case, we're going to say it ends at 0. But do we include or exclude? This case specifically, we actually include because the question includes. The question says, when is it less than or equal to 0? So because that's inclusion. So because they include, we also include. So even if they include, okay, so that's why we include for 0 specifically. However, even if the question includes, we will never include for infinity. Never. Even if the question includes, meaning even the question is greater than or equal to or whatever it is. Okay, we will never include for infinity. That's one thing that's always sure. Okay, so just keep that in mind. So again, if you want to answer it for the other way, which is inequality notation. For inequality notation, this would be x is less than or equal to 0, same as the question, right? Those are silly examples, but it's just an introduction to us. And you have to actually understand it because they can include x being greater than or less than 0 in questions. Right, let's look at the next one. Now, instead of x being greater than 0, they say what? Determine for which x values f of x is greater than 0. So remember, f of x being greater than 0 means what? It means that y is greater than 0 because f of x is y. So f of x is greater than 0 means y is greater than 0. And where in the graph is y greater than 0? Always above the x-axis. Okay, above the x-axis is where y is greater than 0. Always keep that in mind. Oops. Okay, so when f of x, when they say determine the x values of for which x, determine the x values for which f of x is greater than 0, what you need to understand before attempting to answer is that when f of x being greater than 0 means that y is greater than 0, which means that it's above the x-axis. Okay, so now that you have that conceptual understanding of what they're asking, now you go to your graph, okay, and you highlight the part that they're talking about. This is the easy part. Highlight anything that's above the x-axis. So we highlight this guy, and we highlight this guy. Okay, these are the parts of the graph which are above the x-axis, because here's our x-axis. Right, set labels for some reason. Okay, here's our x-axis. Sorry, no, that's our axis. Here's our x-axis. Anything that's above has been highlighted. Okay, so now that we've done the easy part, we've identified that part of the graph which is above the x-axis. We need to now express this in terms of x values. We need to express this in terms of x values. So again, same concept. X is an element of most right value. Sorry, the other way around. X is an element of the most left value and the most right value. Right? And then we can determine differently whether we include or exclude. So just keep in mind for this one, the question does not include. So we're not going to include. Okay, so so this question is going to have two answers because there's two highlighted parts of the graph. Okay, so let's use the vertical line. So the most left value is here somewhere, but we need to understand that it does not stop, because this is just the most left value of this current graph, right? It's not going to stop there because this most left value is going to continue and continue and continue. And that's how we know that's negative infinity, okay? Because it's going in the left direction and it's going on forever. So it's going to go continue more left and more left and more left and more left until it gets to negative infinity, which it will never get because that's what the nature of infinity is. But this most left value here is negative infinity, certainly in terms of x and in terms of y, but we only care about x right now. The most right value, if we draw a little vertical line, is right here. Okay, we will draw a vertical line because remember, a vertical line would touch the x-axis, represents an x coordinate. Okay, so we draw this vertical line, and that represents the most right value, which has an x coordinate of -2. So we can describe this little interval as x is an element of starting value. I never include negative infinity. It starts, its most left value is negative infinity. Its most right value is -2. Do I include -2? Because the question excludes, I will exclude. Okay, let's look at this part. Same vertical line thingy. The most left value of the highlighted part starts here at this x value. Just drawing in a vertical line to represent that. Okay, the most left value is somewhere here, but it doesn't actually end there. It goes on forever and forever and forever, and that is known as infinity. And in this case, because it's moving to the right forever, that's positive infinity. So to answer this, our answer is x is an element of our starting value, which we exclude because the question excludes. It's going to be 1, and our ending value, positive infinity, which we exclude because we always exclude infinity. That's that's the interval notation. Let's talk about the inequality notation. This would be x is less than, so everything less than -2, because that goes on forever. And we don't include because the question doesn't include. And for this other case here, it would be x is greater than 1. See, the thing is, I think many people, like when they hear x is greater than 1, they for some reason think above. Okay, x is greater than 1, so you think above because greater means above. But when it comes to x, remember, x is greater than 1 means everything to the right of 1. Because for x coordinates that are greater, they're more right than, not more correct, but more to the right, the direction right than others. Okay, so always keep that in mind. Anything else? I don't think so. That should be fine. Let's look at the next one. Okay, f of x is less than or equal to, so just the include and exclude, that just affects whether we include or exclude in our answer. Okay, remember that f of x being less than or equal to 0 means what? It means that y is less than or equal to 0, which in turn means what? When is y less than or equal to 0? This is, of course, below the x-axis. Okay, below the x-axis. Okay, so always. So now we do the easy part because we understand what they're talking about. When they said f of x is less than or equal to 0, they meant what? Oh, they just meant the identify the parts of the graph that are below the x-axis. So you highlight the parts of the graph or identify the parts of the graph that they're talking about. Again, that's the easy part. Now to the part where you have to express it in terms of x values. So you're going to say x is an element of the start value and the end value. Okay, so x is an element of basically the most left value, here, right? We're talking about direction. So the most left part of this highlighted part of the graph is right here, right, at -2. And the most right part is right here at 1. Okay, so x is an element of -2 is the start value. Do I include or exclude? In this case, I would include. The reason for that is the question includes. The question says less than or equal to 0. So I would include -2. Just always keep it in mind, right? And that's my start value. What's my ending x value? 1. Do I include or exclude? It's not a turning point. Sorry, it's not an asymptote. It's not infinity. And the question includes, so I include. Okay? So if the question includes, you include. If the question excludes, you exclude. Except for certain exceptions, of course, like infinity, asymptotes, and turning point. Okay, that and turning point, that's just for increasing, decreasing, right? I don't have to exclude turning point here because it's not They're not asking whether it's increasing or decreasing. They're just asking for the parts that are below the x-axis. So just keep that all in mind. And for the other people who like inequality notation, if you really understand that well, you can say here, x is, and not x is an element, but your starting value is going to be -2. Your ending value is going to be 1. So in this case, you always say x is greater than or equal to -2. Okay. Whenever the highlighted portion is between two coordinates, you can say x is greater than or equal to -2, but less than or equal to 1. Okay, but again, if you're struggling, I would really recommend using the first one because that's what we went through. Okay, it would work the same technically for these ones, but yeah. Okay, even in this case, you could say x is actually greater than 1, but less than infinity, and so on, but there's no need to include the infinity there. Okay, x is greater than 1, yeah. Okay, so this should be the answer for this one. Please, if you guys have any questions, or if you want me to re-explain something, let me know. Just by the way, we're going to end at around 1/4 okay, because we started it around, let's say around 1/4 okay. So yes, this is the answer for this. Just to reiterate one more time, f of x less than or equal to 0 means that y is less than or equal to 0, which means it's below the x-axis. So we do the easy part of highlighting the part of the graph that they're describing below the x-axis, and then we do the hard part of expressing it. It's not too hard, but it can get tricky or confusing at times, expressing in terms of x values. So these are the x values. The start value is -2, the end value is 1, and we express those there. Okay. Let's have a look at these quickly. All right. So the first one is determine for which x values f of x is greater than or equal to g of x. Okay. Determine for which x values f of x is greater than or equal to g of x. So we need to understand that f of x is a y. Okay. So this is y. This is the function of y. So y is function. Okay. Greater than or equal to g's function. Okay. So the y of f and the y of g. So it's basically y is greater than y. That's essentially what it is. Now, y is greater than y means that one y value is bigger than another y value. And what does that understand? What does that mean practically on a Cartesian plane? If I have one y value here, it's bigger than a y value there. That always means that if one y value is bigger than another y value, that first y value is above that other y value. So this y of f, y of f being greater than y of g means that y of f is above y of g, right? That's how y coordinates work. Okay, so in this case, right, what's important to understand when they say f of x is greater than or equal to g of x, we're talking about the y values of f being greater than the y values of g, means that f of x, okay, is above g of x. Let's do this in a bit. Like this. Okay, it means that f of x is above g of x. Okay, this is very important for us to understand. F of x being greater than or equal to g of x, okay, because it's y values, right? We're not saying x being greater than x. It's y values of f being greater than the y values of g, means that f of x is above g of x. Okay, and in this, yeah, okay, that's fine for now. And in this case, it says greater than or equal to. So there's two cases technically. Okay, the first one is f of x being above g of x. We have to answer for both, right? And the second one is f of x being equal to g of x. That's essentially what it breaks down to. This is the greater than or equal to, breaks down to the following. Okay, f of x being greater than g of x, or f of x being equal to g of x. That's at the point of intersection. Okay, so now we go to the graph and highlight the part of the graph for which that's true. Okay, we're going to highlight the part of the graph for which that's true. Okay, this is again technically the easy part. So we're going to look for the parts of the graph where f of x is above g of x. Okay, so how do you determine whether it's above or below? You can look at it visually, like use a visual perception of the graphs to see which one's above, or you can consider their y values. So the key thing here is to understand also that they always flip at their intersections. They always flip at the intersections. So whenever they intersect, they flip. So if one was above and the other was below at the intersection, that would flip. I'll show you, right? So we're going to look for the parts where f of x is above g of x. So let's look here. If we look at f of x, so we compare the two, f of x and g of x, right? So they always, the key thing is to always, they always change at points of intersection. Okay, so let's draw a dotted line for our point of intersection here. As well as here. Okay, and we work from between intersections. So we separate it into 3 sections. One is before the first intersection, the second is between the two, and the third is after the second intersection. Okay, 3 different sections. Now, if we have to compare f of x and g of x here, okay, we can clearly see which one is above. Definitely f of x. F of x is above g of x in this particular instance, right, for this particular portion. So f of x clears. Now, let's look at the next part. F of x, g of x. In this case, which one is above? Okay, we can clearly see that g of x is above. Let's look at the next portion. F of x, g of x. Which one is above? Clearly f of x is above. Okay, so that's how you determine which one is above or below for the person that asked. Okay, so you can separate it into, in this case, 3 different sections because they intersect twice. Okay, so always look out for, okay, I'll write a note there at some point, but for when they want to know which one is above which one, we look out for the intersection points, because at the intersection point, it changes. And I should remember, I told you it changes, right? So I'm going to draw the above one in green. Okay, and I'm going to draw the below one in red. So here it's above, here it's below. Here it's above that one, but here this one is below. Here this one is above, and here this one is below. So you can see it swaps, right? F of x goes from being on top to being below to being on top again. And then g of x goes from being below to on top to below. So whenever they intersect, they swap. Okay? And you can clearly see that this entire green part that we highlighted is above the entire red part. That shows that we're correct, right? We've identified the correct parts which are above the other parts. Okay, so just keep that in mind. So the highlighted portion that we are looking for is where f of x is above g of x. So f of x is above g of x in 2 regions. This is the first one, and this is the second one. Okay, so now we need to express those in terms of x values. All right, and let's do that. So we're going to say that the regular x is an element of. So for this first section, x is an element of. Now, keep in mind that the question included, so we will have to include as well. Okay, so this green portion, we need to identify its most left part and its most right part. Okay, now the most left part is located here, but we know that that has an arrow, so it goes till infinity. So we don't include x is an element of negative infinity. Okay, so it starts at negative infinity, and where does it end? It ends at the most right point of that highlighted graph, which is here. And at that point, we need to identify the x coordinate, because we're always giving our answers in terms of x. And the x coordinate there is -3. So it starts at negative infinity, but ends at -3. Do we include or exclude -3? We would include, because the question includes, and it's not an asymptote, nor is it infinity. Okay, so we include -3. So we exclude negative infinity for obvious reasons, and we include -3 because the question includes. For the other notation, this could simply be written as x is less than or equal to -3. Okay, because anything less than -3 goes up until infinity. Okay, let's answer for the next portion of the graph. So here you need to get 2 marks, right? You need to get 1 mark for that and 1 mark for your second answer. So you'd have 2 answers. Let's look at this green part of the graph, and we have to try and give what? We have to try and give we have to try and, of course, express this in terms of x coordinates, right? X values. So we look at the most left value, we look at the most right value that has not changed. So remember, once you've highlighted it, you've identified the correct portion of the graph. So now you just need to express that correct portion in terms of X values. So the most left value is there and the most right value is there. So the X coordinate of the most left value, X is an element of, is 2. And I include 2 because the question includes, so I will include anything that's not an asymptote or infinity. And it goes on, the most right value is there, which is an arrow, which will go until positive infinity. And I never include infinity, of course. So that's the first answer. Okay. And then with the inequality notation, you would just say X is greater than or equal to 2, which would obviously anything greater than or equal to 2 would go to positive infinity. Okay. Come, man. I thought we were going to end on this lesson. We have one last thing to do. Okay, I think we should just do it. I'm just going to use up some extra time. And tell the next lesson that we're going to start a bit late. One second, so we can just spend 10 minutes just answering this, then we can be done with the section and move on to the next. Okay, cool. So let's have a look at this one. Okay, so this was one graph being above the next. Of course, it can change question to question, like maybe g of x being above f of x and so on, but then you can use the same concepts to answer those type of questions. Okay, but the concept is learned here. If you have any questions, please let me know. You have to understand this, right? I know that many people get confused at this, so please, if you have any questions, again, ask. Okay, so let's have a look at this. Determine the values for which these are a bit more complicated examples. Now we have f of x times g of x being greater than 0. So firstly, the way you need to treat this is if you had two random integers, x times y being, let's just say, greater than 0. Let's ignore the equal to for now. If you have two random integers, we call them x and y, being greater than 0. Okay, two random integers being greater than 0 when we multiply them. So basically, this is just saying two random integers giving you a positive answer. So when do you get a positive answer? So when you multiply two numbers, if you multiply a positive and a positive, you're going to get a positive. Okay. If you multiply negative and a positive, you're going to get a negative. However, if you multiply a negative and a negative, you're going to get a positive as well. Okay, so the two possibilities for getting a positive is multiplying a positive and a positive and a negative and a negative. So let's change it around. If we have two integers, right, what if we want them to be less than 0? What if we want a negative answer? Then you're going to either have a negative and a positive or a positive and a negative. These would give you a negative. Okay, so that's the first thing we need to keep in mind. Oops, I need my phone, 1 second. Okay, so yes. Now, when we say f of x times g of x being greater than 0, we literally mean for a specific x coordinate, we multiply the y coordinate of that f graph with the y coordinate of that g graph, and we want to get a positive answer when we multiply those two y coordinates. That's essentially what they are saying. Okay, so when we say f of x times g of x, f of x times g of x to give us greater than or equal to 0, okay, what we have to do is we have to understand that firstly, the first concept that we discussed, anything being greater than 0 when you multiply two numbers. So you can either multiply a positive with a positive or a negative with a negative. Both of these combinations are going to give you a positive or greater than 0. Okay, so, okay, now when we say f of x being positive, what does that mean? It basically means f of x being greater than 0. What does f of x being greater than 0 mean? F of x being greater than 0, we went through it earlier, right? Okay, so let's just do this, right? F of x being positive, what does that mean? F of x being positive means that it's above the x-axis. That's what it means, right? Its y value is greater than 0 also. I'm not going to write that, but yeah, its y value is greater than 0, which means it's above the x-axis. What does g of x being greater than 0 mean? Same thing, above x-axis. So when we deal with the multiplication of the two to give us greater than 0, and when they say f of x multiplied by g of x greater than or equal to 0, and we multiply a positive and a positive for the first instance, we say, okay, in order to get a positive, we can multiply a positive and a positive. So f of x needs to be positive and g of x needs to be positive. What does that mean? Essentially, it means that f of x needs to be above the x-axis and g of x needs to be above the x-axis. F of x needs to be above the g of x. And at the same time, while f of x is above the x-axis, g of x also needs to be above the x-axis. So there's multiple ways you could do this. You could first, the best way I think, is to identify the part of the graph, okay? The part of the first graph, which is above the x-axis, so f of x. This is just solely for f of x. This is the part where it's above the x-axis. That's the part where y is greater than 0. That's the part where f of x is greater than 0. Okay. And then also identify the part of the graph where g of x is greater than 0. And it's this part here. Okay. Now, the thing here, okay, is f of x is greater than 0 from -2 to 5. G of x is greater than 0 from -2 to positive infinity. So clearly they're not greater than 0 for the same x coordinates, all right? It's different. So how do we distinguish? What we can do is, okay, they both start at the same coordinate, which is fine. Okay, so we have our first answer, our first part, because remember we want to answer this for both instances, meaning when it's both positive and when they're both negative. So x is an element of, okay, do we include? Yes, we include, because the question includes -2, because that's where we're going to start, right? They are both above the x-axis, starting at -2. However, g of x ends at infinity, but f of x ends at 5. Remember, the criteria is because we're multiplying f of x and g of x and we want a positive answer, they both need to be positive at the same time. At the same part of the Cartesian plane, both graphs need to be above the x-axis. So that's not the case for the endpoints, because f of x stops being above at 5, but g of x goes till positive infinity. Okay, so the part where they are both above the x-axis stops at 5. Okay, it stops right here. Remember, the key is we need to look for the part of the graph where they are both above the x-axis, and it stops at 5, because at 5, one of them stops being above. So even though the other one is still above, the other one now, what does it do? It starts going below. So anything to the right of 5 is not true for both being above, because as you can see, one is above, one is below the x-axis. We need to identify the part of the graph where both are above. They both start being above at -2, but they, together with them both being above, that ends at 5. Because even though g of x continues being above, f of x goes below, and that's not true. So it ends at 5. So x is an element of starting at -2 and ending at 5. Do we include 5? Yes, we do, because the question includes. Okay, so that's the first one done. Let's look at the next one. It's when they are both negative. Both negative would mean the opposite. F of x being negative would be below, and g of x being negative would be below as well. So we need to identify the parts of the graph. So again, you can do this. You can highlight the part of the graph, like the first function, which is f of x, f of x, f of x, f of x, f of x. Here, f of x is below. And now we identify where g of x is below, and g of x is below here. Okay, so as you can see, okay, sorry, also, f of x is below here. Okay, so f of x is below for both these instances, but we need to identify the parts where f of x and g of x are below, where both of them are below at the same time, okay? Because negative and negative, okay? So in this case, we need to identify the parts where both are below. And if we consider the right-hand side, okay, let's consider the left-hand side. So they start being below, of course, from negative infinity, and it ends at -2. So for these both, for the same interval, both of these are below. Okay. However, here when we f of x starts being below at 5, at the same time g of x is above. So this interval does not hold true for both of them being below. Okay, so in this case, our only answer would be, where are they both below at the same time? It would be this example here. As we can see, the blue and the purple are both below for everything less than -2. So if we have to answer this, we would say x is an element of, they actually, because they both go on forever, they are both below up until negative infinity. So we exclude negative infinity. Okay, and where does it end? Okay, it ends here, because where do them both being below ends? It ends at -2. So we will put -2 and include -2 because the question includes. Okay, so that would be our answer for these. Okay, so let's end it there. Thank you guys so much for joining. Sorry, we won't have time additionally for any questions because we're running so late and I need to start up the grade 12 lesson. Most likely, okay, if you have another way, you can just message it to me and I can just confirm that that would work as well. Okay, but yeah, thank you guys so much for joining. Thank you for your patience as well. Sorry for all the delays today. Okay, but yeah, hopefully next week we'll be back to normal. Good luck. I think you guys are all going to be starting school on Monday. All the best. And please work hard. You guys are reaching the end of the year, right? Work harder than you did in the first 2 terms because your grade 11 marks are important, right? For those of you who want to study, you can get provisional acceptance with grade 11 and you just have to maintain those marks in grade 12. But the fact is you can get acceptance for university degree already with your grade 11 results, which is what you want. Okay, you don't want to have the stress of working even harder, okay, to get your acceptance in grade 12 for those of you who want to study. Okay, so it's really important you guys start working hard. But yeah, thank you guys so much for joining. Again, sorry for all the delays. I will see you guys next week, inshallah. Jazakallah khair. Thank you guys. Assalamu